Hi future doctors, welcome to the next class. So in work done, we were discussing about different cases of work done. Now you will see already on smooth inclined plane, we have seen how much work is done by gravitational force. If an object is moving downwards on rough inclined plane, so rough inclined plane which is having coefficient of friction mu. Then what is the work done by gravitational force? Length of the inclined plane AB is going to be L. How the gravitational force is acting means downwards. If it is theta, if you resolve this one into two components, mg cos theta. This is mg sin theta. Whenever it is moving downwards, in which direction frictional force is going to act? Frictional force is going to act in upward direction. Then what is the resultant force? So work done is, what is our formula? Formula we should not forget. Fs cos theta. So theta is angle between force and displacement. So this theta is different, this theta is different. This theta is angle between force and displacement. So force is in which direction now? Downwards and upwards. But resultant it is moving downwards means this is more. Therefore, net force into what is the displacement? L into what is the angle between net force and displacement means 0. Now what is the net force? Net force means mg sin theta minus frictional force into L. So mg sin theta minus what is frictional force equation? Mu L. In laws of motion we discussed. Mg sin theta minus mu. What is normal reaction here? So this mg cos theta is balanced by normal reaction. Therefore, mu mg cos theta into L. So this is the work done by gravitational force. In this is going to be positive. Why? Because both are acting in same direction. Displacement is along the plane, resultant force also along the plane. Sometimes by work done by gravitational force, we are getting negative. You have to observe all those. Work done by gravitational force or work done by applied force. What they are asking, you have to see very clearly. This is on rough inclined plane. Next up, from a well, you are taking water by standing here. A person is going to pull the water by using a rope. So for this, bucket is going to be there. So mass of this bucket is capital M. He is going to pull length or depth of this well. So then what is the work done by him? Work done by him on the rope if they are asking means if it is massless, mass of the rope is 0, let us assume. Then what is the work he has done means W is equal to gravitational force mg. Minimum force he has to apply mg. What is the displacement? Yeah. So work done by applied force asking means cos 0. Work done by gravitational force asking means cos 180. Therefore, work done is mgl. If mass of the spring is or rope is 0, string is 0. That is it. If they have taken mass of the rope or mass of the string ms, then he is going to bring this string where he is going to apply means wherever we are taking, whenever we are taking any object, where we will apply force means at the center of mass will say. Therefore, on this center he is going to apply. He is bringing how much height means this one L by 2 or H by 2. He is pulling this rope H by 2 height, but bucket H height. Therefore, bucket means mgh. Whenever mass of the rope is or string is 0, if you consider mass of the string also, W equal to work done on this bucket plus mass of the string into G, how much height he is pulling? L by 2. That is only H by 2. L by 2 or H by 2 or depth by 2. So that formula is going to be important. You have to take carefully. Now see, what is the work done by the force, applied force on a rope or chain. So chain is going to be having total length L, mass of the chain is capital M. Then we are applying by a person is going to be applying force F. So whenever he is going to pull this chain like this portion is going to be raised. Where he is doing work means not on this portion. Okay, he is doing work on only hanging portion. So they will give 1 by nth part is hanging. How much part is hanging? L by nth part is hanging. Then where he is applying force means now only we discussed. If L length is there means where he is going to apply force to pull this object means at center. Therefore, L by 2. How much height he is pulling upwards means L by 2. Same like that. Where is the position of center of mass of this chain means its center of mass will be here. Therefore, how much height he is pulling means length he is pulling means h is going to be L by 2n. Total length is here L by n. Therefore, half of this one is L by 2n. So, we got height, how much height we are raising because our formula is W equal to Fs cos theta. Height is going to be upwards. Upward force is also upwards. Therefore, theta is going to be 0. Then F, yes. This S we got. That S how much? L by 2n. That is height. Now, how much force we are going to be applying? That is gravitational force. Means how the gravitational force is acting? Downwards. Minimum this much force we have to apply. Now, what is small m here? What is small m means mass of hanging portion. What is capital M? Mass of total chain. So, if you know small m, you will get the answer. Now, what is small m value? So, how you will calculate means apple problems. 1 apple 10 rupees, 10 apples how much? Mass of the chain for M, capital L. For total length of the chain, mass is capital L. So, we are calculating how much portion of length means L by N mass we are calculating. Therefore, L by N is having how much mass. So, if you cross multiply, so M into L by N is equal to ml. So, if you cancel, small m equal to m by n. So, this small m you can substitute m by n. Now, coming to our formula. So, W is equal to F means mg, S means h, cos 0 because applied force is gravitational force that is in upward direction. If they are asking work done by this gravitational force, then here you have to take minus. Okay, that one you should be very careful. Now, what is small n? M by n g. What is small h? Already we have written there. L by n. Now, what is the final formula? mg L by 2n square. Very, very important formula. Okay, they will give, so L by 1/3 part is hanging. Then what is n value now? If you compare n value 3, then you have to substitute 3 here. So mgl by 2 into 3 square. So 9 2s are 18. mgl by 18. Like that we are going to get. Understood? So once you got understood means this is how much work is done to pull this hanging chain total onto the table. So otherwise how they are going to ask means from n1 portion to this chain, hanging chain is going to bring from 1 by n1 to 1 by n2 they will ask. At that time how we will do means what is the work done? W1 is equal to mgl by 2n1 square, W2 equal to mgl by 2n2 square. So what is the work done means? So mgl by 2 into 1 by n1 square minus 1 by n2 square. So this is going to be work done to pull chain from 1 by n1 part to 1 by n2 part. L by 2 to L by 3 they will ask. Then n1 is 2, n2 is 3 you have to take. So this is how much work is done to pull the chain onto the table. Next one, same chain if they are hanging like this. So this is horizontal surface, you are taking chain like this. So total mass of the chain is capital M. So you are making this one, you are supporting here. How you are making means, so this is the chain means we are taking one end and we are fixing here. Then how much work is going to be done, they are going to ask. Where is the position of center of mass means at center. This is center of mass of total chain. So now you are pulling and you are keeping this one here. So at the time you are doing work on the second portion, not this above portion. This one you are not touching. Now where is the center of mass of this below portion means C1. So from here to here, length is going to be L by 2. Now from C to C1, what is the length means L by 4, and this is also L by 4. Whenever you are bringing here this below portion, the C1 will be coming here. Now what is C to C1? C to C1 is going to be again L by 4. This is going to be L by 4. So from where we brought here, this is L by 4. So finally C1 is coming from here to here means total height how much? How much you brought means L by 4 plus L by 4. That is going to be L by 2. 2L by 4. Correct? This is the height raised by applied force on center of mass of this below portion. Now you have done work on this mass only. Now total mass is capital M means what is the mass of below portion means M by 2. Now what is the gravitational force means mg is going to be M by 2 into g. So now this much force we have to apply minimum to pull this chain like this. Then what is the work done means our formula Fs cos theta. So force is going to be mg by 2. S is going to be L by 2. So applied force means cos 0, gravitational force means cos 180. So mgl by 4. Very, very important equation. So in this case, how much work we have done means mgl by 4. Next, work done by centripetal force whenever object is moving in circular path. Centripetal force will act towards the center. If you leave object here, if it is rotating in anti-clockwise direction, if you leave object here whenever it is rotating, it will move in this direction. If you leave object here in this direction, in this direction, in this direction. So object always moves in the direction of tangent. In which direction velocity will be there? In that direction displacement will be there. Then what is the angle between force and displacement means 90. Fs cos 90. So this is going to become 0. Therefore, they will say work done by centripetal force is always 0. They will be saying. So this is about all work done equations, and another one also will be there, but this equation you will get in fluid mechanics. Some people might have known. So they have taken water or liquid. So in that one object of mass m is going to be present. Water is going to be filled up to h height. So now 5 rupees coin or 10 rupees coin fallen in the water. You are taking that object from bottom to top of the surface. How much work you have done, they will ask. How much force is acting means, so any object which is there within the liquid or water. So on this we are applying apparent weight. What is the apparent weight formula? Mg into 1 minus dl by db. How much height we are pulling? H height. Applied force is in upward direction, H is also upward direction, cos 0 positive. Therefore, work done to pull the object from the bottom of the liquid surface. So mg into 1 minus dl by db into H. What is dl means? Density of this liquid. Water there means density of water you should take. What is dB means? Density of this body they are going to give. At that time you have to use that equation. So this derivation we will get in our fluid mechanics lesson. Thank you.